Welcome, everyone. We're so excited to have you here again. My name is Riggs Kay, and today our creator in residence, Miyaka's Creations, and our experts are going to show you how to make particles using IMVU Studio. They'll show you some advanced options, which are very cool. And we'll also introduce you to some new features and maybe some features that are not even out yet. Is that true? And after the demos, we will answer your questions via our Q&A feature. So please use the Q&A feature to ask questions. And remember to keep your questions on topic and GA friendly. If you haven't downloaded the latest IMVU Studio product, you can find it in a link that I'm about to share with you. You can also find recordings of our past IMVU Studio learning sessions in a link that I am about to share with you. And you can download the IMVU Studio toolkits, which we've talked about before, in a link that I'm about to share with you. Speaking of recordings, we are going to be recording this webinar so that creators who are unable to attend the live session can view it later. Okay, so let's introduce everybody. First, a huge welcome to our creator in residence, Miyaka's Creations. Great to see you, Miyaka.
Hi, hello, everybody. Great to be here.
So glad to have you here. And then we have Mighty Seven and Drosselmeyer, our technical artists. Awesome to have you.
Howdy, everyone. Good to be back.
And last but not least, Tonic, our product director for the creator team.
Hey, folks, glad to be here.
So glad you all are here. Okay, let's get started with the fun stuff. Take it away.
Well, I guess I'll start out a little bit where we've had a lot of people appreciate all of the particle tutorials that we have posted so far, and even Miyaka has posted some particle tutorials and explorations on her YouTube channel, but I don't think any of those tutorials has gotten into some of the more nitty-gritty technical features of our particle system generator, and so we're going to dive into that a little bit more today. And I think first on the agenda, Miyaka, I'm going to hand it over to you, and you're going to show us some stuff about animated textures and some particle helpers and how evolution works.
Okie dokie.
Yeah, sounds great.
Share my screen really quick here.
All right.
And if you can't share, Miyaka, it might be because I have to let you share. So let me know.
Yes, you have to let me share.
Okay, I am going to let you share. I am stopping the share.
Riggs has the power.
I have the power.
Sweet. All right, can we all see my screen now?
Yes.
Yes.
Yep.
Fantastic. So just to start off with, because tomorrow is St. Patrick's Day, I figured that the pot of gold would be a good little thing to play with for today. And this is just a example of like a final product when I was playing with all the features that we have here in the particle section. So let's kind of look at this really quick. So I actually used, for this particular particle system, I used a animated texture map, which is actually 4 separate frames of the coin spinning. 1, 2, 3, 4, and then it has the opacity that matches it, 1, 2, 3, 4, and they're just lined up in order to make the 4 frames. So I'm going to actually remove this so we can start from scratch. So the first thing I'm going to do to add a particle system is you go to the particle section on the bottom here. It's got little pinpoint dots here. And then you can preview it right away to see what it looks like. It defaults at 0, 0, so you can kind of see it pops up down here at the bottom, right at the base ground. You can use the helpers over here to turn on the particles right here, so you can see where the wireframes are. That's a really good tool, by the way, so you can actually see where the particles are being generated and where they are being shot out or whatever. So this one you can kind of see it's the dome. I'm gonna actually move it up here slightly. So the default is the sphere and position is 0. I'm gonna raise it up to 2.
There it is.
Yep, and you can see it popped up. So now it's at the top of my pot here. And then you can adjust how fast that the particles shoot up over here. And then in this lifetime, that's how long the particles will last. I'm actually going to reduce them to 5 seconds. And I want them to shoot up a little bit faster, but with variability. So what, 2, 3 meters per second, 2 to 3. See what happens with that. Yup. So
There
they
they
shoot
go.
a bit higher. And now I'm going to actually add the texture that I pre-made for this. So it's over in the material section. Whenever you make a new particle, it automatically makes a new material. So this is the previous material that I already made, and this is the new one. So you can just add your diffuse maps, or whatever. So I actually made a yellow one and a white one, and the white one, oops, where is it? Is so I can actually add more variability to color later on. So we'll use that one for now. Opacity. And you want to make sure you change this to, is it composite, right?
Right. Yeah. Composite blending.
Composite.
That always works. That always works a lot better for particles, because then you can fade the particles in and out if you want.
Right. And as you see, they kind of like already kind of fade in, and that's because of the default thing down here at the bottom in the evolution and advanced sections. So the evolution is kind of a neat little tool, and you can change the shape, size, color, rotation as the particle, over the lifetime of the particle. And the default always starts with the opacity to 0. So we're going to bring that up. I feel like you guys should change that default.
Yeah, I was thinking the same thing. Maybe we should just make everything not fully opaque, fully transparent when you create a new one. Yeah.
So now it doesn't have that fade when it pops in, and then I'm going to change it to yellow, goldish yellow, because I did make them white. And now they're yellow. To get the animation going, because you see it just has all the frames currently, you go down to the animation section, which is just below the evolution. Everything's in the bottom here. All the cool stuff's on the bottom. This, my particular texture animation is 4 tiles, just 4 tiles wide. And then the range is from 0 to 4, or 0 to 3, 0 being kind of equal to 1, 2, 3, 4, whatever. So you hit the preview button, and then you will see what the actual, oops, sorry, gotta loop it too. That's important too. You gotta actually have a loop. Another thing to point out, that the loop is through the lifetime of the particle. So if it's gonna loop only one time through the entire lifetime of the particle, which is what, 5 seconds, it's gonna take a really long time to get through that one cycle. So you want it to go through more than one cycle. And now the full animation is in effect.
So now the 4 frame animation will loop 10 times over the lifetime of the particle. Yeah, that's why they're moving faster.
Yeah. So if I change the lifetime of the particle instead of the loop, that'll also change the speed of the animation. So I mean, it's best to probably work with the top section and then go down. So see, they get confused, like, why is it going so fast? Well, so another feature with the evolution is you can change the color. So I already added the yellow, and I can actually do a full rainbow if I wanted to, like I had in the beginning. Let's see. So I'm going to actually do that now. So I'm going to change that. It should start with red, and it'll fade to white. And I can duplicate this. Just adds another red one, and then you'll notice that it puts a little number here. This number represents the point in time of the particle lifetime. So since these particles live for 5 seconds, 0.5 would be like 2.5 seconds into the life of the particle. If the particle is 10 seconds, then the 0.5 would be 5 seconds. So it's just the percentage. So let's see, I want to change this to, well, wait. And then I'm going to change this to orange. Get some oranges I can get. So then you'll see it goes straight from red to orange because it's a very short time frame difference. I can duplicate this again, and it just does it automatically adds a halfway point between the two that you make.
Mm-hmm.
Makes the yellow, so then it fades. The reds is quick, and then the yellow orange, the orange yellow to white is a little more gradual. Another little fun thing is like if you start adding too many of these and you want this to be a full one. Oop, what'd I do? I bumped a button. Oh, I can't do that.
Oh, yeah, you can't have two values that are one. Yeah.
0.99.
Yeah.
Okay. If I want, so to avoid to do the math between this one and this one, let's see, this is 0.5. Or it's still 0.1 again. I don't know, just picking numbers. Oh, I can't do 0.1. No duplications, people. If you wanted a more gradual, like the in between of these two numbers, you can use the tween function. So you can either do that with the colors, the scale, or the rotations. I've been just messing with the colors right now, so it'll wait, what I do? Oh, it automatically puts the in between time, but between the color, it just changed the color gradually from yellow to lighter yellow to white. All right, so what else are we gonna do? We're gonna do scale.
Oh yeah, you know what, Miyakas, I think that's actually an important note. The tweening, if you wanted to calculate in between two numbers exactly, I think you can do that on color, scale, and rotation, but not necessarily time.
Not time. Yeah, the time is automatically
Right.
calculated once you add
really
another.
cool. Yeah, but that was a really cool discovery.
Yeah,
I've never messed around with tweening the color before. If you want to get like a nice blend between two colors.
Yeah, so if I turn this
First
one,
time I've seen that. We discovered something new.
ooh. If I turn this one to blue, I actually was playing with this yesterday and I discovered it.
Mm-hmm.
Turn this one to blue and then I tween it. It should turn green if I tween the color. Oh, it didn't.
Oh, it turns gray.
That's interesting. So it's not a perfect science. It does work well on the scales, though. So it would be between the two that you select. So if between 1 and 10, obviously it should turn into 5. 5.5.
Yeah, that makes sense.
So now I got giant coins here. Turn these all back to 1 now. The last thing I want to talk about is the rotation. So since the animation already has the coins rotating and they do pop up at random angles, so it looks like they're rotating in different angles, you can actually have the coins spin as they go as well. Choose in another direction. Let's see here. You're not going to be able to see it super well. I want to actually tween this too. Tween rotation. And you kind of see the coins tilting as they move up and down. if I turn the animation, the tile animation off, it's easier to see. Because there's a lot of spinning going on right now. Just see they kind of shift back and forth. So that's interesting. It doesn't actually do like a complete rotation. It changes direction.
Oh, right, because you're going up to 100 degrees, and then you're going back down to 0 degrees.
That's, oh yeah, it's true.
Yeah, so it's like it's turning, yeah, it's turning a little bit and then it's turning back over time.
Then you go. And I think that is it for me.
Yeah, lots to play with on the,
Yeah.
on the evolution section, and you can have as many. I don't think we have any limit to the number of steps in the evolution that you can have. You can, I think you can rearrange the evolution steps as
Oh
well.
yes, you can change if you set them in the wrong spot. You can move them around, and like having the opacity in there is kind of a nice feature too. It's kind of blends in with the background when it's all the way gray, but
right.
it's
So
there. It's still there.
Yeah. So the opacity is one of the parameters of the color, I guess, that you can set if you want to make your particles disappear or reappear as well.
See how they kind of fade out and fade back in, and then they flash to white before they disappear. Just make them go to 0. All right.
Cool. Thank you.
Thank you.
For that demo. I can't wait for St. Patrick's Day.
Oh yeah. There's so many cool features with the particle system. Like its imagination is limits, and I mean the stuff that you're going to show is really neat too. I mean everything combined, it's so many possibilities. I love it.
Yeah, I mean we were Drossel and Mighty Seven and myself, we were obviously kind of working on the particle system while it was being developed and in process and everything, and we're still discovering new things that you can do, because the one really nice thing about the particle system is it's all about experimentation. Once you understand the basic concepts of how to get done what you want to get done, or trying to produce what you see in your head, the sky's the limit. And there's always these happy accidents that happen as well. I'm always discovering new things that you can do with particle systems.
Absolutely.
Well, I'm gonna go ahead and take over the screen.
All right.
And I have some examples here on a couple of the more advanced features that we haven't really had a chance to talk about a whole lot. And so let's see, can everyone see my screen okay?
Yes.
Am I sharing?
Yep.
Okay.
Yep.
Good. Just making sure. So I just have a generic particle system here that I'm going to use to demo this next section. What you've seen so far, and as was the particle system that Miyaka's was demoing, the origin, she was using a sphere, which is the default. Here, I'm gonna change this to a sphere. And this section, this origin section, the sphere means that the particles can spawn randomly anywhere within the sphere. That's what the origin type means. So the bigger the sphere you have, let me expand the radius to maybe like 3. So, now you notice the particles are spawning randomly anywhere within the sphere. So if I wanted to have like a really small stream of particles, I'd basically just make that sphere a lot smaller. Like if I made it 0.2, and all of the numbers here are based in meters. If that helps sort of visualize. Now all the particles are spawning from a very, very small point. And your origin can be different shapes as well. So you can have your origin point be a box. Let me make that a little bit bigger so you can see it, maybe 0.2, 0.2, 0.2. And again, it's really helpful to turn on the particle helper. If you turn that on, you'll actually be able to visualize the origin points and the sizes and where they are in space. Let me make that like 1, 1, 1, just a better idea of box. There we go. Now you can see. So there's a box shape. Anywhere within that box, that's where the particles are going to spawn. You can also use a cylinder. So there's your cylinder shape. And if you squeeze that cylinder down, so the cylinder is unique because you have a start position of 0, 0, 0. Which is this position right here. And then you have an end position, which I just brought, which is just 1 meter up. And then it basically draws the cylinder. If I were to have the cylinder be, maybe like Y1, Z1, which is going to be over here, if you notice, it will draw an angled cylinder, right? Because the origin point's here, and the end position is over here, so it actually will draw an angled cylinder. So you can actually create some interesting shapes if you're trying to create a particle system around, maybe like specifically around an object that's a specific shape. The other thing you can do, and I'll use the cylinder as an example again. Let me move this back and just make a straight up and down cylinder, and I'm going to make the radius like really thin. Or not, I'm sorry, not the radius, the end position. So it's going to be a very, very thin cylinder like that. Because this is a spherical shape, you can also make the radius, you can change the start and end position of the radius. So right now the radius starts at 0, which is in the middle, and it goes to 1 meter out, right? And then it makes the shape. But what if I made the radius like 0.9 to 1? Then what you're going to see is it's going to start at 0.9 meters and then go to 1 meter. And so if you notice, if I go up like this, it's only generating particles within that donut shape, which is really nice if you have an object that you want, in the middle, and you want particles around it, but you don't want particles going through it. This is a really easy way to generate particles around an object. You just make a really thin cylinder with a thin radius, and then you can get the particles to do that. So moving over to direction is a lot of fun. I'm going to, let's see, I'm just going to change this back to a box. Yeah, let's keep the size where it is. Okay, so back to just a really thin stream. So direction, what we've seen so far is direction as fixed. We haven't really got into these different types of directions, but a fixed direction is basically all the particles will spawn moving in the direction that you specify. So right now, Y1, which means the direction of the particles are going straight up and down. This is kind of an odd way to visualize direction, but if you think about it, if I make Y1 and Z1, that's going to put me into, it's going to average these two values together and give me a direction that's Y1 and Z1. So it's going to be at like an angle. We've thought about making this an angle instead of a normal. And we might end up doing that because, again, it is kind of hard to visualize. If I wanted this to be a little more of an angle, maybe I would make my Z value a little bit less. And you'll notice the angle will be, more towards the Y and less towards the Z. So that's the way you can kind of position a fixed direction.
It
But
does
there's more.
show the red line.
It does show the red line, yeah. So at least you can visualize,
It is faint, but it's there.
Yeah, yeah. And I find, trying to if you're trying to find an exact direction, sometimes you have to do a lot of trial and error. But where things really get fun is the different types of directions. So radial would be the next type of direction. And to show this off better, I'm going to turn off gravity. And I'm going to move the origin point up just a little bit, so it's not in the floor. Okay, so now I have my origin point up a little bit, and if you notice, the origin point is still emanating from the box, but it's emanating in a radial direction. Oh, wait a minute, what's going on here? It's going at kind of an angle, huh? Oh, that's because I have the. Let me do that. There we go. So the particles are emanating radially from the center or from wherever your origin point is. So this is really nice. If I were to slow this down, this would be really nice if you wanted to try to do a like a fog effect that's just kind of emanating from one point really slowly. If you had some fog texture maps there, that would work out really nicely. The next one is cone. This is an interesting one to put together because you need to specify a position above the ground. So I'm going to make a position Y of 1. And when I preview this, notice that it draws a cone from the origin point all the way up to 1 meter, or Y of 1 meter. Let me make that a little bigger so you can see the cone. There we go. And the direction of the particles are going to be any random direction within that cone. So this is really good for fountains. And then the radius specifies the radius of the top of the cone. So if I wanted to make this a little thinner or a little smaller, I'd make the radius, and now we have a bit smaller. And then if I add gravity, right, -1. Now you get something that looks kind of like a fountain. The gravity's taking over, right? But at least the emanation of the particles are happening, radially around this cone. Gives you a nice effect. Let's see. Next on the list is point to particle and particle to point. I'm going to do particle to point because that's the easiest to understand so far. Let's see. The only thing you have in this type is the position of the particle itself. So I'm going to put it out here in space at like 5, 5. And basically all of the particles are going to emanate in the direction of where this point is. I mean, it's being affected by gravity right now. So let me turn off the gravity and that'll give you a better idea, right? So they're basically just going to shoot right at that particle, or right at that point that you designate in space.
Like a
This
laser.
is really nice. I'm sorry?
Like a laser.
Yeah, exactly, like a laser. So you can, this is really nice if you want the particles to be shooting at a specific place on, a piece of furniture or something on your avatar.
The
you can
Death Star.
specify exactly where you want it. Yeah, the Death Star's dead, huh? Because all of these are hitting. The second one is point to particle. This one's a little different. I don't know how many people are going to use this. I haven't really found a good use case to this, but it's basically just the opposite. Wherever this point in space is, the particles are going to emanate away from that point. So if you notice, let me go below the ground here, right? There's the particle, and the particles are moving in the opposite direction of this point in space. We'll see if that comes in handy someday.
It's kind of like a wind.
Yeah. You could think about it as a wind, as like an initial direction. Yeah. And then the last one is random, which is exactly what that means. It will just start emanating particles randomly in all directions. This might be a really good use case for something like fog as well. If I were to slow down the speed, I'm just thinking maybe 0.4, turn the speed way down. Yeah, now you get just a really slow random emanation of particles. Or something like like 4th of July, like sparklers. If you turn the speed way up, but turn the lifetime down to maybe 1 second. And maybe even faster, huh? And maybe turn the rate up to like 50. Oh wow, turn the lifetime down to 0.2. See, you got me playing around now. There we go. So there you go. There, right? So that's like an example of a sparkler, just random direction, little sparks, and the lifetime is very, very short. Let's see what's next on my list here. I talked about points as disks, donuts, spheres, gravity. So there's also a couple different types of gravity. And to show that off, I created this product right here, which is a really good example of, instead of gravity being a direction, like in this example, let me change this back to a fixed direction. Maybe turn that back up to, and turn the speed down as well. So, okay, so we have our normal particle system, and gravity as a direction is normally what you use, right? If I want these particles to start falling back to the ground, I'm going to make my gravity direction -1 in the y direction. And when that happens, the particles fall up and then they start falling back down to the ground again. That's the normal way gravity works. But we also have gravity as a point. And so you can have your gravity be defined as a point in space. And so what I created here, and this took me a little bit of a trial and error, here's my origin point, and I have these particles generating in this direction at a certain speed, and I have the gravity as a point, as a position in space right here in the middle of this ball. Right. And so if I get these particles moving fast enough, the gravity in the that set right here will kind of take over, and it kind of works like a planet, where all of these things are emanating around the planet. If I were to move the scale of the gravity up, let's say like 40. If you notice, the gravity becomes really strong, and it's moving like closer to the planet. Really, this would be really cool for like magic effects and things like that, where you want things to move around. Or if I were to make the gravity less, maybe like 20. If you notice, it's being affected by the gravity, but the particles are kind of not affected enough to be captured.
It's kind of like a whirlpool.
Yeah, if you wanted like whirlpool effect, I mean, if we turn this up to 100, right?
There you go. That's a black hole.
Yeah, there you go. And of course, all these particles are behaving, basically the same, or they're kind of in the same position, because I'm generating it from a very, very small point in space. If I were to increase the radius of the origin to, let's say like 2. Now some of the particles are getting captured and some aren't. Because there's a little more randomness there. So using gravity as a point is, you can get really, really creative with this. There's lots of things I can think of that you can do. Let's see, the last thing that I wanted to show, and I'm just going to touch upon this, is the ability to turn on and off particle systems using our animation system. So let's see, do I have anything else here? Oh, actually, there was one more thing that I wanted to show. How are we doing on time, Rachel?
Sorry, we are we have 24 minutes until the end.
Okay.
Unless we're over.
I'm going to show this. I'm going to show this one more advanced feature, and then we're going to take it off to questions. If you notice here, I'm going to turn off the fire. Mighty 7 made a really awesome fire simulation with 3 different particle systems, but I'm going to turn them all off on him right now because I wanted to focus on the little embers coming up. Now, I messed with this a little bit and I got some nice embers. I'd probably want to make the embers circular, but right now they're actually moving straight up and they're not really working. They don't really feel like embers do, because embers are lighter than air and they kind of move around randomly a little bit as they come up from the fire. Well, there's a way to do that in the particle system. And the way you do that is down in the evolution section, there's a little side menu right here. And you go to advanced features and there are 2 options. One is called random acceleration. If you turn this on, it will, as the particle is moving through space, it will accelerate that particle in random directions as the particle's moving. So when I preview this, you'll notice the effect. So the particles are still being affected by gravity. They're still moving up, generally moving up, but now they're a little bit more randomized. And you can move that randomization up or down by changing the radius. So you can think of this as think of a circle, or think of a sphere around each particle itself, and it's going to choose a random direction around the radius of that particle at that speed. So if I, from 0 to 1, it's going to start moving those particles around just very slightly in different directions. But if I make the radius of the sphere around each particle larger, now it's going to move. Now it's going to push those particles around. It's going to push those particles around even more, right? So now I'm getting like a really huge amount of randomness. Even though the particles are emanating upward, they're getting pushed around in random directions. So that's what random acceleration is. You can see, that almost looks like more fireflies. That would be a really good use case. Or if I calm it down a little bit, it kind of starts to look a little more like embers. Just a little bit of randomness makes all the difference in the world. So the last thing is random displacement. I'm going to just leave that on. And what random displacement does is it shifts the particle in space every frame that it's being rendered. So random displacement is a kind of a very frantic effect. And if you notice, the particles are still moving in space, but they're being shifted randomly in any random direction as the life of the particle continues. So I'm not really sure you can use this for, but I think if you calm it down a little bit, and maybe go like 0 to 0.5. That could almost look like bugs as well. Just a little bit of randomness. And then just for effect, if I increase this to 10, if you think about that sphere around each particle, every frame, each particle is going to be shifted 10 units in any direction. So you're going to get a huge amount of frantic behavior out of the particles when you use random displacement. And there you go. There's our advanced features. And I hope people have a lot of questions, and I hope you use this as an inspiration to really experiment with the particle systems. You can generate almost anything out of this.
There is one question asking about particles attached to an avatar and how that works, if you want to do a quick thing with that.
Yeah, particles attached to the avatar work exactly the same way. In fact, I have I think the quickest way to show that off. Let's see. Let me yeah, let me just change my outfit. I have an outfit here.
Particles are built the same. You're just deriving from a different source.
Right. You can attach a particle to anything at all. And if hey, come on. Am I changing clothes? There we go. So here's an example of a particle system on an avatar. And in the particle panel, oh wait, no, here. Yeah. In the particle panel, the node feature here, if you were attaching a particle system to an avatar, you would get all of the bones of the avatar here, and then you can choose to attach the particle system to any one of those bones. And right now I have this particle system attached to her wrist, and particles emanate in world space, so it's really nice when you have something like an animated let's see, I have this dance, there we go. The particles will follow that bone around and give you some really cool effects in that sense. So there you go. The last thing, let's see. I think we should probably move it into questions since we're getting a little bit low on time. I was going to show let me just show one advanced feature that's not released yet, but we're working on it. It's probably going to be released in a few months, and that is an artificial rim light that you'll be able to apply to your models in IMVU Studios. We're testing this right now, which means you can define a color, and you can define an intensity, and you can put that on any material, and it will add a color around the edges, around the backside edges of whatever material you apply it to. And what it does is it simulates an artificial backlight on the object. And so we're playing around with it right now, and hopefully it'll be out to everyone in the next month or so. And I think we can probably open it up to questions.
Awesome.
I'll go ahead and stop sharing for the moment.
Okay.
You're so amazingly thorough. There are no questions.
I know.
Whoa.
And we covered everything, right?
Let's see. Rana asked, is it possible to have future code to make it go around? I think we'll probably need a little bit more detail on that question. I'm not quite understanding.
She was asking earlier about particles and the avatar, and whether they would like pass through the avatar, which they do. But I think what she's wondering is, like, would it be possible to have the particles sort of like collide with or move around the avatar or avoid the avatar? And I kind of don't think so, because then you would have to have like collision detection, and in our engine there's actually like no physics, no collision detection whatsoever.
Right. You probably could mistake it a little bit by having the particles behave in local space instead of world space.
Possibly.
And that way, like the example of the wrist particles, Right now, as her hands and arms are moving around while she's dancing, the particles are staying in world space, right? But if you change that to local space, as she moves her arms around, the particles are locked to that bone in her arm. And if you have particles moving like maybe around her arm, like almost like a particle bracelet, it'll stay stuck to her arm, and it won't behave, with gravity or anything like that. And that's just a big button at the very top of the particle panel. You can have particles behave in local space or in world space. You can switch either one. I think we might have answered that. She said, okay. Thanks, Rana, for the question.
Yeah.
And we've gone through the demo of the latest features, right? Already, the panels and the room deco, is that what we?
I didn't quite cover those because I wanted to switch to questions, but yeah, let me share my screen again, and I'll just remind everyone of those features. These features are out already. This first one was by popular demand. A lot of creators didn't like the fact that the two main panels are on either side of the screen. And so we added a little feature here in the corner. This is a kind of a shortcut where you can choose to have your panels both on the right side of the screen or both on the left side of the screen, or the way we have it now, which we're calling standard, or either side of the screen. And once you change your panels, they'll stay that way across projects until you change it back. And then the last feature that we just introduced in this last release is Room Deco 2.0, which has been out on IMVU desktop for quite a while, and everyone is really loving all the new features on Room Deco 2. If you haven't gotten a chance to try it out, please do. There's a whole set of instructions that Rachel can post the URL to, with a video learning and everything like that on it. But there's a lot of new features here that aren't even available in Classic. You can copy the properties from one piece of furniture to another. A lot of really cloning and duplicating and scaling tools. The tools available to rotate are much like what you would see in a 3D editing suite. So it makes it really easy to just grab things and move them around, rotate them, move them around in space, just like you would in a 3D software package. And there's a lot more here as well. You can drag and drop items like directly onto the scene. Lots of stuff here. It's all in IMVU Studio now. And if you like the changes that you made to the room that you're using, you can even upload the state of all the furniture in the room up to your live room if you want. Or you can reset the state back to what has been saved in your live room. So there's a lot of interactivity and a lot of availability there for everyone. And those are the two new features. Yeah.
We've got one more question about cloning poses for a derivable product.
And who made the cute bunnies?
I know, those are so cute.
Yeah, I found them in the catalog. I'm not sure who made them.
Yeah, the duplicating animation feature has been requested for a while now, so I don't know if that's in any sort of timeline at all.
Oh, so you're saying just the ability to like in the component panel to be able to just duplicate an action?
Yeah.
Yeah,
Redo all your work?
yeah. I've gotten that request several times too.
Yeah, that is in our backlog. We really need to get to that. And I think it would be really easy to implement. Maybe we'll, since other folks have requested it just now, we'll move it higher up on our agenda and try to get that out to you guys in the next few releases.
Yeah,
Yay.
it would definitely save a lot of time when you're making a multi-pose / animation product / avatar.
Yeah, that makes a lot of sense.
Anything else? Oh, we got one more. We got two more. We've got, is there a way to quickly get rid of all of the unused textures?
Oh, yeah, I want that too. Yeah, I think there's not even a good way to like select multiple assets and then delete them all. You have to do them individually, which is kind of a pain. So no, not yet.
Yeah, I was wondering in the asset, if you go into the asset panel and you delete unused assets, do they still show up in the texture list?
I think it removes them from the disk from your project folder.
Yeah, I think they go away.
Yeah, they go away, but
Go
you
away.
you have to do them you have to do them individually, which is kind of tedious.
Oh, yeah. So we're talking about a feature where you can just like bulk delete unused assets.
Yeah, delete unused or select multiple and delete. Of course, you can't delete things that are in use, but
Right, of course.
Yeah.
Yeah. I'm gonna make a note of that. Let's see if we can get that up on the priority list.
cool.
You guys would be scared to look at our backlog list of things that we can add to IMVU Studio.
Oh, it's
Sometimes the hardest thing is deciding like what feature are we going to add next, because the list is very long. But these look like these sound like a couple things that are low hanging fruit that we might be able to add pretty easily.
Rana wants a vote.
Wants to vote.
Yeah. We could do a community vote on all
Yeah.
the features that we want to have added.
That would be a good way to find priority.
Yeah, I don't think that's too far from the possibility. We could set up for the handful of features that we're in question on. You know, if there's a bunch of stuff that we internally have a question on, we could probably set up a poll in the discussion forum in the IMVU Studio discussion forum, and then just put it out to everybody.
Yeah. And it would be interesting also to add like how long, you know what I mean? Like how many hours or something to give people an understanding of what the scale would be in terms of how long they would, you know, how much work it would take and which would translate into how long it might take.
Yeah.
You know, it would be a nice transparency thing. I don't know if you could do this, but if you had like your to-do list somewhere on the website, and then you can have like a pending or like on the list of being worked on now or future something. I don't know, that would be a transparency thing, but I don't know how much you want to reveal of what your future plans are, you know?
Well, no, I mean, at least for the feature requests that, you know, are not like, you know, months of work, you know, things that might be, you know, like 2, 3, 4 days of work to implement, we could probably put a lot of those requests up and or at least expose our backlog list of kind of smaller items that we want to get to. Yeah, I think that's a great idea. We'll definitely
that's really good. I think it's mostly just a logistics thing, like trying to get it up there and maintain it.
Yeah.
And did we cover the inventory management question?
Let's see, where was the inventory management?
It's is there going to be, will there be a feature that allows people to manage their inventory in desktop?
Oh, yes, that's I know that's one of the top features. That one's one of the larger features, at least on Studio, that we have to get parity on, that already exists in the classic client. It's on our list. I can't say when it's going to be available, but we're definitely trying to get to it, and we're not forgetting about it. That's for sure.
Awesome. Any other questions? Great idea so far.
Done.
Going once, going twice. And no more questions with 5 minutes to spare.
Ooh.
Well, thank you so much, Miyaka and Mighty Seven and Tauntaun and Drosselmeyer for doing such a great job demoing and answering the questions. And thank you, everybody who's listening, for asking such great questions and attending. We really appreciate your time and attention and enthusiasm for IMVU Studio. Have a wonderful morning, evening, or late night, depending on where you are in this world. And we will see you again soon.
Thanks,
Yeah,
everybody.
Great. Thanks for having me.
Thanks, Miyaka. Thanks, everyone.
Bye.
Bye.